This is the part 1 of the array series that I have planned. In this series, we will cover from the very basics of an array. Then we will discuss about algorithms that quite frequently get asked in the companies. And then we will go on to solve some hard level problems and techniques that actually get asked in companies like Google, Amazon, and Microsoft. What is today's this video's agenda? We will discuss about very basics of an array, how to iterate over an array, how to reverse an array. But this last one, that is to rotate an array without using extra space, is quite not intuitive. If you are already good at array, you can skip to this part and you can watch this part. Okay, without further ado, let's get into the video. Let me explain this with a real world example. What are actually arrays and why do we even need them in computer? Alright. So, what are the quick observations that you can draw when you see this egg cartoon and the eggs? The first observation that you can draw here is these are homogeneous. That is, all of them are eggs, right? You cannot remove an egg from this and you cannot place a book. Similarly, you cannot remove an egg and place a glass. All of them are eggs and you can remove an egg and only place an egg. That is the first thing. Arrays are homogeneous. That is, it will have a similar data structure. For example, if it is an integer array, it will have only int. If it is a string array, it will have only strings. Okay. What is the second observation that we can draw from this? It has a fixed size. For example, you want to place the seventh egg here. Can you place it? No, right? Similarly, if you want to break it without modifying this, can you reduce the size to 3 without breaking it? No, right? That's the second observation, that the size of an array is fixed. What's the third observation that we can draw? The location is continuous, right? It's not like there are two eggs, then there is a gap and there are other spaces, right? These are continuous memory allocation. So what are arrays? They are homogeneous fixed size data structure that are actually continuous. Let's look how it is actually stored within the computer. Let's take an array of size 5. So let this be the base address of the array. Okay. So what will be the next address list? For this example, let us take the size of the int to be 4. Okay, 4 bits. So what will be the next location? Since it is continuous, it will be stored at 1004. Similarly, 1008. We are just adding 4 to this location. So they are stored in continuous location. One more thing in array is that here we can number them from 1, 2, 3, 4, 5, 6. But in arrays, we have 0 indexed. What does it 0 indexed mean? It starts from 0. This is 1, this is 2, 3 and 4. Though the size is 5, it starts from 0 and ends at 4. Why do we actually do this? Right? Why? Because, see, for example, the base address is 1000 and you want to find the third element here or this element in this. What I can do is 1000 plus 4 into 3. Whatever is the size of this into 3, you will directly be getting. Similar in this case, if you want to access the third egg, right, you can directly access. In the same way, you can just access this particular thing in one shot. So what is the advantages of array? If you want to pick any element from any position, you can just do it in constant time or very fast time. But what are the problems with an array? Suppose, or for example, let us take this example only. So if we want to remove the egg from here and want to shift the other two eggs, right? We will remove this fourth egg and we want to place the fifth and sixth egg at fourth and fifth position. This will actually take a lot of time. So that is one problem that we encounter with an array. That is insertion and deletion both might take n complex time. That is the size of this time. Those are the two problems. But the advantage is you can quickly access any particular space that you want. That is the advantage. So how do we access a particular element in an array? This is how we access. Say for example, you need the third element, that is this element. You just call a of 3. Similarly, if you want the first element, you will call a of 0. So how do you iterate over this particular array? You will have I is equal to 0 and this is how you will find the length of this array and you will just print each of them. This is how you access all of them. Now let's do a quite simple problem. you have to find the maximum and the minimum of this array. What can you do? You can just create two variables, that is int max and the other one will be minimum, where both of them are equal to the first element. Okay, no need to initiate these two other values. We can just initiate this to the first value. So whenever we go further, we can change the maximum and minimum values. That is, if a of I is greater than the current maximum value, we can just change the max value. Similarly, if it is lesser than the current minimum value, we can change the minimum value. That is how you can find the maximum and minimum of a given array. Okay, let's get into the next example of how you can reverse an array. Just before that, I want to discuss how you can swap two elements. For example, you want to swap this element and this element. How do you do this? It's very easy. So we will have a temporary variable created. What do? We will just take one of these values and we will use a third variable, that is temporary variable, and store it here. So whatever you have stored, you can change it to the other value, and whatever this is there, you can just copy it from here. It's a very simple thing. You just use a third variable and swap these values. Okay, now let's look into how you can reverse an array. What does array reversal means? That is, the entire array is reversed. For example, this is coming here, this is coming here, and the entire array here is reversed. So if you look carefully, what we can do, we can create one more array, and what we will do is we will just place the first element at this position, the second element will be this, the third element will be this, the fourth element will be this, and so on. What are we doing? We are creating one more array, that is B array, and we will just allocate that. What is the other idea that we can use here? The other idea that we can actually use here is we can just swap the element. For example, if you look here, is these two elements are just swapped in the answer, 8 and 4. Similarly, 1 and 7 are swapped here. Similarly, 6 and 3 are just swapped here. So what is the answer here? What we can do is we can just swap the elements, but be careful, we have to swap only till n by 2, that is half of the array, otherwise you will be getting the same array in the end. So what do? We iterate over to n by 2 and we will swap the elements. Once we swap the elements, we will get the particular answer. Okay, so next let's discuss a very interesting problem. How do you rotate an array by k times? For example, this is the original array, so we will rotate it by 1 time. So what does the rotation mean? That is, every element is shifted to the right, that is clockwise. For example, this 4 is shifted to the next position, I will be shifted to I plus 1 position. For example, 4 is shifted here, similarly 7 is shifted, similarly 3 is shifted. But what happens to the last element? The last element just becomes the first element in the first rotation. Similarly, in the second rotation, what is happening? Everything is shifted right and the last element just becomes the first element. So how do you rotate an array k times? For example, you want to rotate this particular array 3 times. So how do you do this? Let's think of a solution. One way to do this is we will do the same step that we discussed, that is shift the right. That is, we will swap these elements one by one and the last element will become the first element. But if you want to do this, it will take a lot of time, right? You have to do this k times. The same thing, you have to do it k times. Suppose you are given k is equal to 4, you have to do the same procedure 4 times, and this is a costly process. So one quick solution that we can do is we can have an extra array, and what we will do in this extra array is, for example, here is the input array, right? And k is equal to 3, we want to rotate it 3 times. What do? If you look here very closely, the 0th position is replaced by the third element or the kth element. Similarly, k plus 1th element. Similarly, k plus 2 element. But if you go here, it has to be replaced by k, that is 3 plus 3, that is 6. We simply can do percent, or we can get the modulus of this by the length of the array, that is 6 percentile 6 or 6 modulus 6, that will be equal to 0. and you will just get this particular array. Similarly, this will be equal to 7 percentile 6 or 7 modulus 6, that will become this element, right? So here's the quick code for that. You can just replace this 3 by k. What are we doing? We are just changing the values from this array. But here if you look, we are using an extra array. Why do we want to use an extra array? Because we cannot directly swap them, right? We have to hold the values. You cannot change the particular cell's value. So the original data will be lost. So you can use an extra array. But can you do this without using an extra array, without using any extra space? Okay. If you look here very closely, you will find something very non-intuitive here. So if you look here very closely, this part is equal to this part. This array is rotated k times. So what is happening here? This part has become this part, and this part is just the first part, right? What is happening here is the first part has become the second part, that is 0 to k minus 1 has started from k and is ending at n. Similarly, the k to n has become the first part. So what can we actually do here? One thing is, if you look closely, we will just reverse the first half. That is 473 will become 374. Similarly, 618 will become 816. And what do? We will reverse the entire array, right? What will be the final answer? 6, 1, 8, 4, 7, 3. If we reverse this entire array. So what is the first step? We will reverse from 0 to k minus 1, and then from kth element to the nth element we will reverse, and at the end we will reverse both of them. So previously I have discussed how to reverse from 0 to n. Instead of using n, you can just use k minus 1 in the first half and from k to n in the second half. So that's it from my side, friends. Please do like and subscribe the video. Thank you for watching the video.